Welcome back everyone to Data Science for Everyone. Today we're going to be looking at exploratory data analysis with Python. Let's get started. So we're going to be using some house pricing data and we're going to be doing an exploratory data analysis as we just stated. And we're going to be going through a couple different steps. We're going to be doing some data exploration, some data cleaning. Maybe if we get further enough, maybe we'll do some data modeling. But today I think we're going to just stick with some data exploration and data cleaning. So the first thing we want to do is let's go on and get our imports in. So let's import pandas as PD, import Seaborn as SNS. I don't like the import NumPy as MP. And then let's also do import matplotlib.pyplot as PLT. And then we'll also do matplotlib inline. Run this. And let's go on and input in our data. So we'll call this just a data frame, and we'll do pd.read CSV data, and I believe I called it houseprice.csv. We'll see here in a second if that's it or not. What do we name it? Prices. Okay. House prices. That's CSV. And we'll do df.head. Let's take a look at our head. And so we have in here some ID, a subclass, some zoning, lot size, street and alley, lot shapes, contour lines, whether it has a pool, all kinds of nice information. Years sold, and again, what we would want to maybe do some sort of prediction modeling on would maybe be the sale price of the house. So let's go on and also get up some information. And take a look here, and we see that there are a bunch of different object types here, okay? So we probably will need to do some sort of fixing on those to make them usable, so since they are of the categorical type in nature. So let's go on and do a couple other things. So if we go, and we can see here that there are definitely some missing data. So let's go on and actually take a look at that as well. So let's do something like df.isNull.sum. You can definitely see here we do have some that are quite large. So what we would want to do usually when we do this, you want to kind of check and see, for example, if you at least have, if there's like maybe 20 to 30% missing, I would maybe drop the column. Okay, and this would also go just as well for the rows as well, okay, because again, those observations are just going to be kind of messy at that point. So let's go on and write up something that'll deal with that. And let's say that let's say we want 30%. So let's say we want to drop column if 30% is missing. Okay, so we can do this a couple different ways, but we'll do this creating a df2, and let's say the data frame, and we want to do this with a count method. So let's do something like call in a data frame if the data frame column dot count divided by the length of the data frame is greater than or equal to 0.3. Okay, and the reason we do this before I even go into that in detail is actually we can do something very similar to this. So if we do df.count, okay, and we do something like divide by length of df. Here it gives us actually a percentage of how many of what potentially could be missing. So for example, here, if we have 30% or more, we're going to be keeping it. Okay. So if I do something like greater than equal to 0.3. So here we get trues, there's some falses. So again, as long as there's at least 30% of the data here, we're going to keep it. So maybe if we wanted to bump that up to like 70%, we could. Okay, it just depends on what you would like to do. So we're going to go on and do that here. And then we also want to go on and delete from df2. We want to delete the ID column because it is going to be useless to us. Because if we saw up here, it's basically just a number, okay? It's just a count, okay, of who's in there and who's not. So let's go on and run that. And let's also go on and list out any of our dropped columns, because whenever you are running through anything and you're dropping things out, people want to know why you dropped it out, what you dropped it out. So this is basically telling us, all right, we're dropping things out very well, but then here it's also going to say what we dropped out. Okay, because you need to tell them when you drop it out. So columns dropped, and then we'll do something like what here? End is equal to just a space. Okay, so it's not going to have that new line. Print. Let's give it just a nice little pattern there. And again, we want something like end is just a space. So for C in df dot columns, if C not in df2 dot columns, we want to print C, and here will be, whoops, excuse me, will be a comma with the space, and then we'll do something like what? Nah, I think that'll be fine. Whoops, that did not go as planned. I don't want this. Let's make it look clean. There we go. So again, or we could have done something more like this and done end is a space. There we go. And so we have this nice little kind of list. So again, we got rid of alley, pool, QC, fence, miscellaneous. So let's go on now and get a little bit of a descriptive statistic with maybe our variable of interest here, which is going to be our sale price. So let's do something like df2 dot describe. Here, descriptive statistics look fine. This is a little messy. Maybe we can round the whole thing. So we'll do round by what? Round by 2, let's say. There we go. So now it looks nice. And this is good and all, but this doesn't give us a nice kind of visualization of what's maybe going on with the data, particularly because a lot of this data is also not, it's non-numeric, okay? A lot of our variables aren't, so we'll have to deal with those as well. So let's go on and take a look at our distribution of our data here. So let's do SNS. Oh, and one thing here I should show. Let's go all the way over to our price. Notice this, okay? This is the max on that price. So we have some really high valued items, and then we have some relatively low valued houses as well. But now we need to see, is this normally distributed? How does it actually look to us? So SNS dot let's do, I believe discplot is what it's changed to, and we want to look at our sale price. And let's do bins here of 100. And then we also want to actually give in here our hist arguments so that we can change what it looks like. Let's give it an alpha of 0.5. There's one discplot. Yeah, it's going to have a future warning, and that's okay. So here we can kind of see that there's definitely a skew here, all right? So there's probably a couple values that are pretty high up there that we may need to deal with, but that's quite okay. So another thing that we want to do is go on and grab up our numerical data. Okay, so our numerical data, if we want, so df num here is going to be our df2.select here, and we want to exclude here our D type of O. Okay. Well, df2. Oh, does anyone not want that? Oh, whoops, it's not select. It's a select D types. Sorry. Okay, so now if we look at df.num.info, okay, it's going to grab all of our integers and our floats because, again, we are excluding objects. Okay, so we're excluding any of the strings or anything else. Now, you could also do something like include, okay, but then you would have to say you want to include float 64 and integer 64. You'd have to actually type out a little bit more. I like to just say, all right, I'm excluding just the objects. Now later on, when we want to look at just the categorical variables, we can say we want to only include this O to grab all of our categoricals. And we can actually, we'll do that here in a minute. So let's go on and take a look then at maybe doing a histogram here and maybe looking at all of the data itself. So let's do something like df num dot hist, and let's make this big. Let's do a 20 by 20. Bins here will be 50. X label size here, let's make it 10. Y label size here, we'll also make it 10. Let that run. All right, and again, it's going to give us a couple warnings here. But again, I just wanted to do this nice and quick. We can also use like the pair plot, that type of thing. But I just wanted to see each of them as they are. Okay, so again, notice here, oh, you can't see it because of my face. Let me do that. So here we have our year built. And you can see here that this is just going to tell us when the houses were built. We definitely had a building boom here. Okay, we have all kinds of, even though that some of these, like for example, this full bath, these other types of baths, they're numerical in nature. Technically, they're not though, because they're more of a category. They're just telling you how many there are. They're very discrete in nature. All right, so whether they have garage areas, that looks relatively uniform. Okay, year sold. Notice here that it's very, this data set is kind of from 2006 to 2010. And our sale price here, again, has this nice long tail at the end. So we can go through and let's look at maybe the correlation between all of the numerical values. So let's do something like df num correlation. So df num dot core. And we want to look at everything in terms with the sale price. And then we'll do -1. Okay. So because again, the last row in this is the sale price. So I just want to drop out that sale price so we don't have a redundancy in there. And then let's also look at, let's do SNS dot heat map here of df num core. Oops. Oh, it's because it actually wants the other. We can do here we go. And you can see that we have this nice little heat map. Now these are great and all, okay? But if you notice, there's too many, okay? So we want to kind of see here, there are a lot of these that don't have, that are actually pretty highly correlated with one another. There's some here that aren't correlated at all. So let's actually see what the most important values are that we can find. Okay, so basically in conclusion on this, what are our golden features? Okay, what are the most important? What is the strongest correlation that we can find here? So let's say something like the strongest correlation with sale price. So let's do something like important features. Here we'll do df num correlation, and we want something like the absolute value of these df num core, and let's do that is greater than, let's say greater than 0.5. Okay. So these are things that are highly correlated. And let's do sort values, and we want this to be ascending, or well, descending technically. So ascending is false. And so let's do print with an f string, and let's say something like there are, let's say, length of important features. There are, let's say, 3 important, there are 3 strongly correlated features with sale price, and then let's have it actually maybe list those out. Let's just run this and see how that works. All right, so there are 10 strongly correlated features with sale price, and then how would we like this to actually be seen there? So let's do something like important features. Yeah. Okay, so then we can actually see that in here. We can see them all here. So this overall quality is highly correlated. And the lowest here we have the remodeling addition that was built in the house. So this is great. Now we know which ones are strongly correlated. Let's also see then about doing a little bit of a pair plot. We want to see the relationships, okay, between all of these values here. So let's do something like for I in range 0 to the length of our data frame df num dot columns by 5. And this way here is you're technically doing a pair plot, but we're only going kind of like 5 at a time. So and then we're going to be running through them so that it looks kind of nice here. So we can do pair plot. Data here would be df num. We want our x variables here to be df num dot columns. And then here we need I through I plus 5. And then y vars here is going to be our sale price. and let that run for a second. And then we can see that there is definitely a nice little correlation we can see here. And you can see that we're just doing kind of 5 at a time so that we can see them in a little bit easier light here. Definitely there is some kind of grouping here, and there's also a lot of, notice, let me zoom in a little bit. Here, I can't really show you very well, but there's a lot of zeros, okay? They're kind of stacking up there. So we're probably going to need to take care of those values because maybe, depending on what this data set was going on, okay? Maybe that means that there were maybe some missing values. So for example, like if there wasn't anything in there, okay, so maybe they just didn't have that data, then it was 0. Maybe there was something else going on with it. So let's go on and remove some of the 0 values, okay, so that we can also have a nice clean conclusion on that. So and we'll after we remove those, we'll end that here. This is starting to get a little bit long, and we'll continue next time as well. So let's do import operator. So, and then we'll do individual features. Data frame is going to be just some list here for I in range from 0 to the length of, let me zoom out a little bit. The length of our num.columns here, and we want -1. Since the last column here is again going to be the sale price, let's create a temp data frame here, and we want df num.columns 0, not 0, we want I. And then we want what? Comma, sale price. And then from this temp, we'll do something like temp is equal to our temp df dot num dot columns of I that are not equal to 0. Oh, and I actually want this to move 1 over to here. And then we have our individual features dot append our temp data frame. Okay, and then so if we look at our individual temp features here, we can see that it's a bunch of little column, a bunch of data frames in there inside of the list. So let's also go on and create up an all correlations here, and this would be our features in here. And how do I want to go about doing this? Let's see here. Let's do feet dot columns 0 such that feet dot core of sale price of zero for feet in our individual features data frame. So this is using our a dictionary extraction in here. So let's do all core so you guys can see here. So it's a nice dictionary. And then we'll also go on and do something like all core is equal to sorted all core dot items. Key is going to be here our operator dot item getter of 1 because we want them by the items. And then we'll do for key value in all correlations. Let's print. Here we want, what do we want in here? let's make it nice and pretty. So we want our key greater than 15 with a colon and a space, and then we'll do something like our value colon greater than 15 to make it nice and pretty. And we can actually see here the correlations that we have for all of the correlations. Now, again, what we'll see here is we need to also look for some highly correlated values after they've been cleaned. Okay, and this is going to be the last step in this particular process, okay, looking for our highly correlated or strong correlation, okay? So we're basically going to need to redo our important features, okay, to see what we're wanting to do. So let's go on and update this one last time, okay? So our important features is going to be key for key value in all correlations. If the absolute of the value is greater than or equal to 0.5. Okay, and then we'll print something like, what did we put up here? Let's put the same thing. Oops. There we go. So here we have 11 now, okay? We added a new feature, and again here we actually have, now we just made this a list, okay? So we actually have just the names. So we have some strong, all of the strong predictors with, I wouldn't say they're strong predictors, they're just highly correlated with sale price. Later on, we'll maybe do some, create some dummy variables with the features. So overall correlation of our numerical variables, we have discovered that we have 11 strong correlated features to housing price. And besides the correlation, we didn't really find any notable patterns so far, but we'll look at that in the next episode. If you guys like this, please comment, subscribe, and hit that like button, and I will see you guys next time. Bye-bye.